Hi, welcome to Debug School. This time, better check yourself. The scientific method. Sometimes when I'm helping a friend debug a problem, they would say to me, "That's impossible. It can't possibly happen." And then they would show me that it can't possibly happen because they've already verified this and they've already verified that. As if they found a smoking gun that proved that they were right and therefore their computer must be wrong. Now, while computers have been accused of being drunk at times, a much more probable explanation is that this is simply a case where a strongly held assumption is mistaken. We are biased about the code that we write. After all, they're like our babies. We made them. When we write any program, we hold assumptions about the code. And this is natural. It's necessary, even, because unless you make assumptions, you cannot plan. And programming is an activity that requires a lot of planning. However, in the context of debugging, clearly something is wrong. Things are not going according to plan. If something defies logic, that means at least one of your assumptions are wrong. Your job now is to figure out which one of those it is. You need to get suspicious. It is kind of like when you know you have a mole in your spy agency and you really need to find out who it is. So in that situation, what do? Do you trust your gut? The mole is there precisely to deceive you, and he or she already has a pretty good track record at doing that. If you continue to entrust this to your gut, you could spend all the time in the world accusing innocent people while the agency slowly disintegrates. In bug tracking terms, you could be going around in circles indefinitely and never resolve anything. Instead, you would be better off by being more scientific. Via the Wikipedia, the scientific method is a body of techniques for investigating phenomena, acquiring new knowledge, or correcting and integrating previous knowledge. So, when we encounter a bug, we're going to look at our program as if it were a phenomenon, a sort of black box that behaves in a certain way, something that we don't quite completely understand yet, but we're ready to learn more about through scientific investigation. Here is the recipe for the scientific method. The first step is you ask a question, and then you come up with a hypothesis, a sort of guess at an answer to the question. And then, based on that hypothesis, you come up with a prediction that can be tested with an experiment. The fourth step is to actually test that prediction by running an experiment. After running the experiment, we analyze the results and come up with a theory that explains those results as well as other existing evidence that we have. If there isn't enough data to form a theory, we go back to step 1 and ask another question. And we repeat this cycle, and we'll do it over and over again until we do come up with a satisfying theory that explains the original question. Now, let's put the scientific method to the test. I'm going to debug this program, and this program's job is to read in a text file containing a paragraph of text. Then it's going to go through each word in the text, count them up, and then at the end, print a summary of each word that appeared in the paragraph, as well as the number of times the word appeared in the paragraph. First, I'm going to run this program, and as you can see, when I run it, nothing happened. You might be wondering why. Good, because that's exactly the first step. So, like a good scientist, I'm going to be taking notes. Scientists write in journals, but I'm just going to use another text file. I'm going to call this file debugging notes. So question 1 is, why is nothing being printed? Now, I need to come up with a hypothesis. For that, let me review this source code a little bit. So this program is pretty well organized, and it has 4 main sections. The first section scrubs the text and removes the punctuation. The second section splits the paragraph into individual words. the third section here goes through the words and counts them up. And then the final section here loops through the summary and prints them out. So clearly, the last section is responsible for printing things out. And if nothing is getting printed, I can guess that the summary is empty. So hypothesis is the summary is empty. Now I need a prediction based on that hypothesis. My prediction is if I print a summary to the console on line 24, then it will print an empty object. Let's test that out. So on line 24, we will console.log summary. Let me run that. And indeed, it is an empty object. So we have confirmed the prediction. And for the analysis part, I'm just going to say for some reason, indeed, summary is empty. But why? Why is summary empty? So now I've went through one iteration of the scientific method steps, and I'll repeat it again and again until we find the root cause of the problem. Again, let me look at the code. The summary variable is declared and set to an empty object on line 12. So presumably the lines between 14 and 21 here must be responsible for populating it. As a sanity check, is it even looping through the words? So my hypothesis is the for loop that's on line 14 may not even be iterating the words. And if that were the case, that would explain why the summary object did not get populated. So my prediction is if I print out some dummy text within the for loop on line 15, that dummy text will not get printed even once. Now let's test that. So on line 15, I will console.log some dummy text. I'm going to do my favorite. Toby was here. Let's run the program, and indeed, none of that text got printed, which confirms my prediction. And for the analysis, I'm going to say for some reason, the for loop on line 14 did not iterate any words. Why isn't it iterating the words? Well, what if the words array on line 9 were empty to begin with? So based on that, my prediction is if I were to print the words array on line 10, it will be an empty array. So let's test that. I'm going to console.log the words array, run it, and there are actually words in that array. Curious. So this time, my prediction was wrong, and the experiment disproves my hypothesis. So the words array indeed contained words, but for some reason, the for loop does not iterate through the words. The next question naturally would be, why doesn't the for loop iterate through those words? Let's review the code once again. So there is this for loop, and it's trying to iterate the words, but that's not working. My hypothesis is, well, maybe the stopping condition of the for loop is erroneous, and that's preventing the loop from iterating. So prediction, if I print the stop condition of the for loop before the for loop starts, it should print false, because that would explain why it never iterated the loop. So let's test that prediction. There's a little hiccup here because I need the variable I to be initialized in order to even execute this condition. I'm going to need to extract this initialization outside of the for loop. Then I can console.log the expression in the stop condition. Let me run that. And indeed, the stop condition is false at this point. So that confirms my prediction. Analysis. The stopping condition is indeed erroneous. We expected it to be true, causing the iteration of the for loop, but this is false. Next question then naturally would be, why is the stop condition I less than words.length incorrect? Well, there are only two values. I should be 0 because I had just set it to that. So my guess is that words.length is incorrect and does not return the real length of the array. Prediction, if I print out words.length on line 16, it does not print the real length of the array. So to test that, let me print that out. Let me run that, and indeed, it did not return the length of the array at all, but instead it printed undefined. So that confirms my prediction. My analysis is words.length is incorrect. Okay, so why is words.length incorrect? At this point, if you're familiar with JavaScript, you probably have already figured it out. The length property should be lowercased. So my prediction is if I fix the casing to lowercase length, then it will correct the mistake and the program will work correctly. Let me test that. So I'm going to fix the casing of words.length in both places and run it. And indeed, that worked. The word summary is now printed as designed. So I'm really glad I got to the bottom of this. My final analysis and diagnosis is that the mistake that caused the program to malfunction was the miscasing of the length property. Finally, now that I've solved this problem, I had better go back and remove all the extra console.log statements that I added. Now let me just run it one more time to see that the program is working as it was intended. And it is. One time, one of my students, Paul, came to me for programming help. And he said something along the lines of, "It's not working and I think I know what it is." And then he would tell me his hypothesis. So then to that I would say, "Okay, now go verify it." When he hears that, he grumbles and then he settles down and makes an effort and eventually comes up with a way to test his theory. And this helps him make progress towards solving the problem eventually. What I'm wondering now is why did he have to come to me just so that I can tell him to test his hypothesis? Because clearly he has done steps 1 to 3 in the scientific method, but he stopped short before step 4. Why? One reason is that he simply hasn't been following the scientific method, and that is why I'm putting together this lesson here. But there's also another reason, and it's a psychological phenomenon called the Streetlight Effect. And here's the story associated with this phenomenon. On a pitch black night, there is a guy, let's call him Charlie. Charlie is crawling on all fours under a street lamp intently looking for something. Charlie might be a little drunk. A policeman sees him and comes over to help. "Hey, Charlie, what are you looking for?" Charlie says, "I'm looking for my keys." The policeman helps him look, and they look all over and all around, but they haven't found the keys. So the policeman says, "Charlie, are you sure you lost your keys here?" And Charlie says, "Well, actually, I think I might have lost them at the park." The policeman says, "Well, if you lost them at the park, then why are we looking here for the keys?" And Charlie says, "The park is pitch black and I couldn't see a thing over there. This is where the light is." People often look for the thing that they are looking for by looking only where the looking is easy. But this is a dead end if what you're looking for is elsewhere. In the previous story, Paul was stalled when he couldn't readily come up with a way to test the hypothesis that he came up with. And this is akin to Charlie not wanting to search for his keys in the park because it's too dark. When Paul came to me, all I had to do to get him to test his hypothesis was to make him think harder. And the same thing could be applied to Charlie's situation. How can I effectively search for keys in the park? Oh, I know. I could bring a flashlight. The streetlight effect is something that occurs a lot, and so we need to be able to overcome it. Here's how. First, follow the scientific method. Make sure you don't skip on the 4th step of testing the hypothesis. I have personally been in situations where I've acted upon untested assumptions and then ended up wasting both my time and my coworkers' time. Second, know your tools. Two common reasons for ineffective debugging that I've seen are not knowing your tools well and not knowing that a certain type of tool exists. When you know your tools well, it's like having a flashlight by your side for nearly every situation. Third, if it's not obvious how to test a hypothesis, take a step back, brainstorm, research, and ask other developers. Doing this will also help you come up with more than just one way to test a hypothesis, which is very useful for situations when you want to be extra certain of something, and also for situations where certain tests simply do not work or are unreliable. That concludes this lesson on the scientific method. I'm going to leave you with some exercises to chew on. Please work on these because it will force you to apply the concepts of the lesson and thus retain it for future use. See you soon.